All right, so now let's talk about something pretty important, which is the criteria for causation. There are three requirements that you have to have in order to talk about causation. And so these are empirical association, time order, and non-spuriousness. Now, there's sort of two other helpful criteria, which are not required, but really sort of help when you're trying to explain a relationship. And this is mechanism and context. So let's talk about each of these. So empirical association, so this is basically correlation. This is saying that variation in one variable is related to variation in another. So as something goes up, something else goes down, or as abuse in childhood increases, then in an area, then that area is going to see more crime happen in adulthood, and violent crime, domestic violence, or something like that. So as one variable goes up, another variable goes up. Or something simpler, as education goes up, income goes up. So these are it's just correlation essentially, because and the relationship has to be observable, so it has to be something that we can actually measure in some way. But basically, the independent and dependent variable are varying together, which is why it's correlation or covariation. And so this is sort of an important thing, because if two variables aren't even related, then of course one isn't causing the other to happen. So this is the most basic step, but right off the bat, correlation does not imply causation. That's going to be an important thing I'm going to keep repeating, because correlation is not enough to say something is that one thing is causing the other thing to happen. And I'll tell you more about that when we talk about spurious, non-spuriousness. But so the first step is that they've got to be related, which makes sense. But then the next requirement is what's called time order, which basically just means that the change in the independent variable has to happen before the change in the dependent variable. So the change in the thing that you think is having the causal effect has to happen first. Because if the thing that is being caused happens first, then of course it's not being caused by something that hasn't happened yet. So the change in the independent variable, the one that's doing the causing, has to happen first. And this is just something simple, like you flick a light switch and then the light comes on. So if the light was already on and then you flick the light switch, clearly that light switch didn't turn that light on. So that you have to be able to know that the change in the independent variable happened first. And so this sometimes is like a chicken or egg kind of debate, but in something like a light switch and a light, that's pretty simple, but it's often not super easy to figure out that time order. For example, if you're looking at something like the relationship between drug use in juveniles and general criminal lifestyle within a juvenile population, then if you say, well, okay, so is it that kids are doing drugs and that causes them to commit crime? Or are they committing crime and then drug use is just part of that criminal lifestyle? So time order is kind of difficult there, because there might be some causative relationships happening there, but how do you figure out if the drug use happened first or if it happened after the criminal lifestyle had already begun? And that can sometimes be difficult to sort of tease apart. So something like something in childhood affecting adulthood, time order is pretty easy there. But if we're looking at stuff that's happening at the same time, it can be difficult to tease that stuff apart. And then non-spuriousness. This is kind of the why we can't say correlation is enough to say that something causes something else. So non-spuriousness is the idea that we want to make sure the relationship between the variables are not because of variation in some third variable. And so that there's not actually some external variable that's affecting both of our variables and the original two variables aren't related at all. And they're just both, they look like they're related because they're both being affected by some third variable that we're maybe not accounting for. So when you have that third extraneous variable, meaning it's just external to the original two that we're looking at, you have that third variable that's causing the variation. That's a spurious relationship. That means that the independent and dependent variable they're going to be correlated. They're going to look like they're related, but it's because of that's a spurious relationship, and it's because of that third variable. So a spurious relationship is what we don't want, which is why we want non-spuriousness. And so random assignment to groups can really help reduce the threat of spuriousness, because if we're sort of comparing two groups on something like whether they got some treatment or something like that, like anger management, and then we want to see if that therapy helped reduce recidivism. Well, random assignment to who gets that and who doesn't can help it be that, oh, well, it's not just because whoever wanted the anger management therapy is already more likely to change. So if we randomly assign them, then that it won't be because of some third variable like willingness or motivation or whatever. So randomly assigning people to groups can help reduce that threat, but of course, when we're dealing with people, it's not always easy or ethical to have that random assignment. So, but it doesn't mean you can't address possible threats of spuriousness. It just means that it's not an easy fix if you can't randomly assign. And so here's where correlation does not imply causation. So just because two variables are related doesn't mean one is causing the other, because it could be some third variable affecting both of them in some way. So here's some examples of spurious relationships, so what we wouldn't want to have happen. So here's one. So we would look at something like ice cream sales and crime. So, and it is definitely, it's a correlation that as ice cream sales go up, crime goes up. But that's not because people are buying ice cream and going crazy on sugar and going out and committing crimes. There's no causative relationship there. Ice cream sales are not causing crime to go up. What's happening is that it's because it's hot outside and it's summertime, and so during the summertime when it's hot outside, people buy more ice cream, and during the summertime when it's hot outside, people commit more crime, which is an established relationship. So it's the causation that's happening is actually between the heat or summer, and that's causing increases in ice cream sales, and that's causing increases in crime. But these two variables are gonna look like they're related, but they're not. That's a spurious relationship. Here's another one. If we look at the number of fire trucks that are dispatched to a fire and the amount of fire damage, there's going to be a positive relationship there, which means that the more fire trucks that we send to a scene, the more fire damage there is. But that doesn't mean, oh, let's just stop sending fire trucks and that'll stop the amount of damage, because it's not the fire trucks causing the amount of damage. It's because they're both being affected by the size of the fire. Bigger fire means you send more fire trucks. Bigger fire means there's going to be more fire damage. So it's not that we don't have the number of trucks that they're not causing the fire damage. They're going to be related. There's going to be a positive relationship there, but that correlation does not imply causation. That just means that they're going to be related, but that's a spurious relationship. The actual causative relationship is between the size of the fire and the number of fire trucks, and there's another causative relationship between the size of the fire and the amount of fire damage. So those are causative. The original one, that's a spurious relationship. And then I like this sort of way to round things out. So I used to think correlation implied causation, then I took a statistics class. Now I don't. Sounds like the class helped. Well, maybe. Hopefully you understand that joke, because correlation does not imply causation. All right, so those are the three requirements to be able to talk about causation. So you have to have the empirical association, you have to have time order, and you have to have non-spuriousness. If you have those three things, you can say that there is a causative relationship, as well as given whatever evidence that you have for all those three things. But the next two things are sort of helpful ways to help explain that causation, and which can help strengthen your your claim that you have a causative relationship. So mechanism, basically it's the process that creates the connection between the independent variable and the dependent variable. So it's basically saying how or why that relationship exists. So if you can explain why there's a causative relationship, then that confidence in that relationship is going to go up, because you can say, well, yeah, there's an empirical association. I can show that the one doing the causing is happening first, and this is not because of some third extraneous variable. There is an actual causative effect, and here's why I expected that relationship in the first place, which is why this is where theory comes into play. And so if you can use a theory, sort of theoretical background to explain why your two variables should be related in the first place, then that helps to strengthen that claim that you have of, well, yes, this is causative because I've met all these requirements, plus it makes sense from a theoretical background that these should be related. So the mechanism is basically explaining why there should be a causative relationship between your two variables. And then context is the other one that's kind of not required, but it helps if you can explain the context. So the context is basically the context surrounding the event or situation that you're talking about in terms of causation. So no causal relationship can be separated out from some larger context that it happens in. So a cause then is just one of a whole set of interrelated factors that are required for your effect. So if you can explain, well, maybe this situation is why we see a stronger empirical association in this group versus this group, but it's there for both of them, but it's stronger here, and here's why. It's kind of, again, explaining why that relationship exists in the first place, and sort of explaining that it's part of all of these things in motion that happen, in tandem with this initial variable, and that, it's more likely to see with, if you're looking at comparing the genders, or you're comparing different areas or something like that, and you can explain how the context fits in to your overall relationship. So it's not required to talk about causality, just like mechanism is not required, but it helps. If you can explain that, then it helps to strengthen that claim to say, yes, these variables are causally related. This one is causing this change in the dependent variable, and here's why, and here's the context that helps explain why we have that relationship. So mechanism and context are really helpful, but they're not a technical requirement. But typically, these are part of the explanation when somebody is talking about causality. All right, so those are your main requirements for causality. Remember the three required: empirical association, time order, and non-spuriousness. And then mechanism and context are kind of helpful, but they're not required. And that's the requirements for causation.